For Chapter 8, Day 8, we're going to talk about the graphs of the tangent and reciprocal trig functions. Now, during a normal school year, we would have you, as a warm-up, go ahead and identify the values in those tables of tangent of x, cotangent of x, cosecant, and secant of x. But given the remote structure and the time constraints during this school year, we're going to go ahead and fill these in for you. If you want to copy them down, you're more than welcome to. But the most important thing is that you recognize these specific coordinates for the base functions of tangent of x, cotangent of x, secant of x, and cosecant of x. So if we notice this table, we see that tangent of x is at 0, 0 for 0. At pi over 4, which is somewhere in this region between 0 and pi over 2, it's going to be at 1. And then at pi over 2, it's going to be undefined, which can look like a vertical asymptote. And then at 3 pi over 4, which again would be in this range, so we can actually fill these in if we want, pi over 4, 3 pi over 4, it would be at -1, so we'll put the -1 on there. And then at pi, it's back at 0, and then at 5 pi over 4, we see it's back at 1, and then again an undefined asymptote. So you can see here as we're filling this out, there's a pattern where we have asymptotes, and it is increasing from left to right within those asymptotes. So the general graph of a tangent function looks like this, where there are asymptotes and it is increasing from left to right inside those asymptotes. Now, with this in mind, like we do with the other ones, you can apply phase shifts, vertical stretches, horizontal stretches and compressions, reflections. So we're going to take these parent functions and we're going to apply those transformations to be able to graph these. But within that, we got to understand all of these things here, the amplitude, period, asymptote, just like we normally do with our sine and cosine functions. So the amplitude is, again, the vertical maximum and minimum is undefined for a tangent function because obviously it goes up and down forever. So there's never really that maximum and minimum to have an amplitude. The y-intercept for our tangent of x function is going to be 0, 0. Now again, obviously if we make a horizontal shift, it will move. The period, if you notice, the period for a tangent function is actually not 2 pi, right? How long does it take to do one cycle before you restart back down at the bottom? So here we start at the bottom, we go up, and then we restart back down here. How long does it take for us to get through one cycle? Well, pi over 2 to 3 pi over 2 is going to be pi. So the period of a tangent function is actually pi. Okay? The asymptotes of a tangent function can be found. Again, for tangent of x, we're starting at pi over 2 is one of them. And then because it happens each period, you can find them by doing pi x or pi k. Okay? K being the general however many cycles you want to run through. So if we take a look now at the domain and range, the domain is forever, just like our sine and cosine function, from negative to positive infinity. However, it does not include the asymptote. So it would be all real numbers. That's the symbol for all real numbers, except pi over 2 plus pi k. Because again, these tangent graphs go left and right forever. They can be cycled throughout eternity, but they do not include those asymptotes. So except pi over 2 plus pi k. The range, that one would be negative to positive infinity because, again, we said they go up and down forever. So that's the parent function, the base function of tangent of x. Again, we can apply our transformations, vertical shifts, horizontal shifts, stretches and compressions, and it will adjust these. But if you're graphing just tangent of x, then that's what we're going to have as our domain, range, amplitude, y-intercept, period, asymptotes, and all that good stuff. Now looking at the reciprocal trig function, again, you see a similar pattern, but for cotangent, if we graphed all these points, you would notice that it actually goes down, it decreases. So at pi over 4, it's actually 1, and then it goes through 0 at pi over 2, and then hits that minimum at 3 pi over 2, or 3 pi over 4, where our vertical asymptote is at pi. So we have a vertical asymptote on the y-axis, vertical asymptote at pi, and then again, as we go through, you notice that it is decreasing, where again, there's a vertical asymptote at 2 pi. So if we're filling out this background information for just cotangent of x, you're going to notice that the amplitude is again undefined because it does go down, up and down forever. So amplitude is undefined. The period is still just pi because, like we said on the last one, to get through one cycle before we restart at the top, it only takes pi units from 0 to pi. The y-intercept, you notice there is none because there's an asymptote on the y-axis. And now for this one, it's similar because you're adding or subtracting pi k, but the difference is we start at 0, so it's just plus or minus pi k. The domain is very similar. It's all real numbers except plus or minus pi k, which are our asymptotes, and then the range, again, would be negative infinity to positive infinity. So like the tangent function, you want to make sure that you remember the cotangent function just as we did sine and cosine. So when we apply those transformations, you're able to graph cotangent of 2x, 3 cotangent of x minus 5, all that good stuff. On the next page, again, continuing with what would have been the warm-up, we're going to talk about the reciprocal trig functions for sine and cosine. So for cosecant, again, if we graph all of these, you're going to notice that at pi over 4, it is at root 2, square root of 2. And then at pi over 2, it's at 1. And then at 3 pi over 4, we're back at square root of 2. You notice at pi, it is undefined, so that's our vertical asymptote. And then at 5 pi over 4, we're down at negative square root of 2. At negative 1 for 3 pi over 2. Oh, sorry, negative 1. And then at 7 pi over 4, we're back at the negative square root of 2. And again, a vertical asymptote at 2 pi. So you notice, again, we're dealing with asymptotes when it comes to the reciprocal trig functions. This is our cosecant graph. Now, one thing to note here is if you look at the sine graph, sine of x, let's compare it because it is a reciprocal trig function, so we want to look and see if there's any sort of connection. Remember, at sine, the range is from negative 1 to 1, right? So for sine, you start at 0, 0, and you would go up, max out at 1, where we're meeting here, down through the origin, through the central point, bottom out again where we meet again, and then back to 2, 0. So if you notice, those major points where the sine function is crossing that x-axis, that is where our vertical asymptotes occur, right? So where where sine is 0, those are vertical asymptotes for cosecant, because think about it. If sine of x is 0, sine of pi is 0, the reciprocal, 0 over 1, the reciprocal is undefined. That's why for cosecant, it would be a vertical asymptote. And then likewise, if sine of x is 1, well, the cosecant, 1 over 1, just reciprocals, is just 1 over 1 again. So when we graph these, and we're going to show you in a minute when we get to the examples, when we graph these, we're actually going to graph the sine function first, and then knowing those major points at the maximum and minimum, and then the x-intercepts, we're just going to graph the cosecant function off of that. Okay? But that's the relationship between cosecant and sine, and it's going to be really helpful. But right now we're talking about the cosecant function. So the amplitude of the cosecant function is undefined, because again, it goes up and down forever. The period of a cosecant function, while remember for tangent, we were going between the asymptotes, A period means how long does it take before you recycle. So even though we're doing that full parabola in that first section of asymptotes, we don't restart up here in that next section. We're still continuing a different graph, and it wouldn't be until after 2 pi that we actually start back up here again, where we're restarting that cycle. So because of that, cosecant is just like sine, where the period is actually 2 pi, or 2 pi over b. The domain is going to be all real numbers except the asymptotes, again, because you don't include asymptotes in your domain. So since we start at 0 and each asymptote is occurring pi units away, it's all real numbers except plus or minus pi k. The range for this, again, it starts at negative infinity and it comes up to negative 1. It includes negative 1, but then it restarts at positive 1 and goes to positive infinity. So our range is going to be from negative infinity to negative 1, skip to 1, and go to positive infinity. So again, this is because it is the reciprocal of sine that we have to recognize that relationship and then adjust accordingly for the domain, range, amplitude, and period. The last one we're going to talk about is the secant of X function, which, as you can probably guess, would have a similar relationship in terms of how it relates to its cosine, the other reciprocal. So if we go ahead and graph these just like we did the cosecant graph, we have those in between. So if we use the table, again, pi over 4, 3 pi over 4, pi, 5 pi over 4, 7 pi over 4. You notice we start at 0, 1. At pi over 4, we're at root 2. And then again, an asymptote, this time at pi over 2. And then down here, we're at negative root 2 for 3 pi over 4, negative 1 for pi, back up, asymptote, and then here, and then at 1 for 2 pi. So the graph of our secant function looks something like this. Again, if it's just secant of x with no shifts or transformations. But again, if we represent it based on its counterpart, cosine of x in the blue, remember for just y equals cosine of x, you start up high, you're going to come down through pi over, you're going to come down through pi over 2, because at pi over 2, cosine of pi over 2 is 0. You're going to bottom out at pi, because the x value of pi is going to be 0, or negative 1, and then you come back up, and you're going to max out at cosine of 2 pi is going to be 1, and then you're going to restart your graph. So just like the other one, the maxes and mins of the cosine are the maxes and mins of the reciprocal function. They're just flipped outward. And then the x-intercepts of cosine are going to be your asymptotes of secant. So if we go ahead and identify the amplitude, again, would be undefined. The period is still going to be 2 pi because it's going to take 2 pi units to cycle through 1. And then the domain, again, is going to be all real numbers except this time our asymptotes start at pi over 2. So it would be pi over 2 plus or minus pi k, because there is a new asymptote every pi units away. And then the range, again, would be negative infinity to negative 1, just like the cosecant, and then from 1 to infinity. So these are the 4 remaining trig functions that we haven't graphed yet. So we know sine and cosine. I just told you, and we're going to do a couple examples where you graph cosecant and secant based on sine and cosine. But we also need to make sure that we know the tangent and cotangent ones from that front page. Okay? So on the next page, we got 3 problems here we're going to go through, and we're just going to graph one period of each. So for the first one, it says graph y equals 2 tangent of pi x. So just like we do in the other problems, we're going to find the period first. The only difference is, remember, it's normally 2 pi over b. This time it's going to be pi over b because it's a tangent function. We said the one period of tangent is pi units. So one period is going to be 1. So we're going to do 4 tick marks out. Is going to be 1. Cut it in half. Cut it in a fourth. So here is our scale. Here's our scale for the function we're talking about. Then we know that for tangent, because there's no shifts left or right, we know that for tangent, we're going to start at the origin. And our amplitude, we didn't write this one out here, but we should write the amplitude, is going to be 2. So up here we got 2. Down here we got -2. So we know at 1/4 we're going to be at 2. The asymptote is 2 tick marks out. And then again, we would start back down at 3/4, cut through the origin at 1, because that's, again, 1 period away. 1 period away, we should be in the same spot. And then again, up top at, let's say, 5/4. And then the next one would be 3/2. There would be another asymptote. So we graphed a little bit over 1 period, but that's what our graph should look like. We should probably curve this a little bit more if you wanted to draw that. So we ended up graphing 2 periods, but that's what it should look like. If you wanted to graph 1 period, you can either take this out, or you can take out this second half, which is probably the part that we want to be talking about. Okay? X-intercept, you notice, is going to be at 0, 0 within our first period, and then 1, 0. The y-intercept, we notice, is at 0, 0. And then again, the asymptote, for this case, because we're only having 1, let's take this out, because again, we're only graphing 1 period. So let's follow directions. The only asymptote we're talking about here, x equals 1/2. Now, if the question said, recognize all asymptotes, well, then it would be 1/2, 1/2 plus or minus 1/2, because that would take us to the next one. Sorry, 1/2 plus 1, because we get 1 every period. So that's how you graph the tangent function. If you want to take a look at the next one, it says graph y equals -2 secant of x. So the first thing we want to do when we're talking about secant and cosecant is we first want to graph y equals -2 cosine of x. By graphing this, it's going to make it significantly easier to graph the reciprocal trig function. So if we graph this one, we have the period is still going to be 2 pi. It's going to be the same. Let's say period is 2 pi. So 1, 2, 3, 4 is 2 pi. Pi over 2, 3 pi over 2. For cosine, because the amplitude is 2, our max and min are going to be 2, but because it's negative, we're starting at the bottom. We're going to come up, max out, down. So this is our, again, make sure you understand this is our cosine function, not the secant function. Now, the only thing we have to do after that is take that max and minimum, find the x-intercepts, those are our asymptotes, and then flip it outward, because we're talking about that reciprocal trig function. So once you've graphed the cosine function of the almost identical problem, then you can graph your secant function. So we have the period is 2 pi, because it's going to match the cosine period. The x-intercepts, remember, for the secant function, we don't have any. We have x-intercepts for the cosine function, but we don't have any for the secant function. The y-intercept, we do have one at -2, 0. And then the asymptotes for this one would be pi over 2 and 3 pi over 2. So again, understand the blue one is not part of a graph. The blue one is more of a guide to help us graph the one that we need. And then the last problem here, we're going to do the cosecant one. So again, let's graph its counterpart, 1/3 sine of pi x, where the period would be 2, because that's 2 pi over pi, and the amplitude would be 1/3. So if we go 1, 2, 3, 4 tick marks, we got 2, 1, 1/2, 1.5. Amplitude is 1/3. -1/3 is our minimum. And then if we graph sine, again, there's no vertical or horizontal shifts. So we're going to start at the origin for the blue one. That's our sine function. Go up, back down, bottom out, and then back up. all x-intercepts become asymptotes, and then all maxes and minimums become our locations for our max and min for the cosecant graph. In order to match, remember that the cosecant function has the same, it's just 2, not 2 pi, because the period of sine is 2. The x-intercepts, again, there are none for our reciprocal trig functions in this case. Y-intercepts, we don't have any because there's an asymptote on the y-axis. And then asymptotes in general, we have x equals 0, x equals 1, and x equals 2. Okay. So again, the best way to graph your secant and cosecant functions is to graph your sine and cosine functions first and use those as a guide. The tangent and cotangent functions follow the pattern on the warm-up, and you should be good.